Hi, everyone. Happy Wednesday. We're almost through the week. So today we're going to be talking about natural disruptions again and kind of what happens after a natural disruption if it's bad enough, which is mass extinction. So we're going to be talking all about the 5 different previous mass extinctions and a little bit about the one we're going through right now. All right, so natural disruptions, it's not all our fault all of the time. Right now, it's all our fault, but previously. So it's not all of our fault all of the time, but right now it is. So some natural disruptions that can occur. We can have forest fires. Unfortunately, we are starting to have those more because of us. Volcanic eruptions, we don't control that one at all. Earthquakes, that one can be sometimes our fault, which we'll talk about later on. Plate tectonic movement, obviously not our fault. Changes in solar radiation, asteroids, weather, and also changes in greenhouse gases, which are sometimes our fault, sometimes not our fault. So these are all natural things that can occur naturally that can disrupt an ecosystem. And typically, if they're really bad, these are most of the time, these are just going to disrupt. It's going to be fine. Not a big deal, whatever. Sometimes these are so extreme that it's going to cause extreme climate change. And when there is extreme changes in climate, we're going to see mass extinctions. So typically for there to be extreme climate change, one of these has to be really bad or there has to be multiple at the same time. So for most of the previous mass extinctions, it's been that there's been multiple of these pretty much for most of them. So after a disruption, organisms have a few options. They could alter their behavior to adapt to the new environment. They could migrate, so find a new, better habitat, or they could die. So obviously they're probably going to try one or two, and if one or two don't work for them, they're dead. So a good example of this is the Sahara Desert. It at one point was a forest. And then due to extreme climate change, it became a desert. And those organisms, they just migrated further down south in Africa. So it wasn't really a big deal for them. If at least 50% of all organisms on the planet go extinct, it's considered a mass extinction event. So let's say a disruption, a bunch of species start dying, 50% of them to be exact, it's considered a mass extinction. And this has only happened 5 times throughout history. So the previous mass extinctions, the first one was the Ordovician Silurian extinction, 444 million years ago, with 85% of all species dying. The late Devonian extinction, this was 383 to 359 million years ago, 75% of all species died. The Permian Triassic extinction was the worst extinction in in Earth's history. It was 252 million years ago. 70% of land, 96% of marine species went extinct. Total, I think they estimate about 94-95% of all species on Earth went extinct. Triassic-Jurassic extinction, this was 201 million years ago, 80% of all species. And then the Cretaceous-Paleogene extinction. This is the one that got the dinosaurs, and that was 66 million years ago and killed 76% of all species. So typically for these 5, there's going to be a lot of different things that really cause the mass extinctions to happen. The 6th mass extinction, welcome. It's currently happening as we sit here, which is yikes. And it's caused by us, mainly climate change, habitat destruction, and pollution. Mass extinctions take place on a geologic timescale. So this is going to keep happening for hundreds of thousands of years if we don't do anything to stop it. But they know that we're in a 6th mass extinction based on our extinction rate right now. It is as high or higher in some cases than what it's been during the previous mass extinctions. So basically, it's if we do stuff to lower that rate, the 6th mass extinction might not really happen. But if we don't and we keep that extinction rate as high as it is, then in hundreds of thousands of years, it'll be considered a mass extinction. So remember, we're talking geologic, so it's not lots of things are dying right now, but 96% of the species aren't going to be dead within 100 years. So I know it's kind of hard to wrap your head around the geologic timescale. All right, so interactive notebook time. There's a video that you need to watch, and then you're answering the questions. It's a video from SciShow, which is another one of my favorite YouTube channels. If you get a chance, you should watch more of them. Also, happy spooky season. If you have any questions, remember office hours are 2 to 2:20, and you can find the link in your Google Calendar. All right, I will see you guys later. Bye.